Hello, this is Mr. Humbart here. I'm going to make this video about the time derivation of the solving for position no final velocity given part. This is a little bit of a longer segment because I have to talk about the quadratic equation here. So, not that I can't do that, so let's talk about that. First off, the quadratic equation is something that I'll just briefly go through. It's a way to solve for a variable if you're given this type of polynomial. So if you have some x squared, this is called general form, and that equals 0. This ax squared plus bx plus c equals 0. And you want to solve this for x, you have to do a couple of extra steps here involving some factoring and some different things. So first thing we need to do here, we have to subtract c to both sides. We have to, once we do that, divide by a squared, or no, just a. Divide both sides by a. Break things up. So that's going to be x squared plus b over a x equals negative c over a. And I'm leaving space for a reason. So what I need to do now is I need to find something that's going to factor this. So I'm going to find a number, or not a number, I'm going to do this. I'm going to add this b over a term and divide by 2, because this is going to give me what's called a perfect square. I'm going to square that, and I'm going to add this on the other side as well, so I don't break any rules. And once I do that, I can factor this. So I notice I divide this b over a by 2, I square it, I can factor that as x plus b over 2a. Because if I add these together, I will get b over a, because 1/2 plus 1/2 is just 2 over 2, or b over a. And if I multiply them together, I will get b squared over 2a, which is what I have here, over 2a squared, which is b squared over 4a squared. So now that I know that, I can set this equal to b squared minus all over 4a squared. And we want to find a common denominator here because we have a c over a. We need to multiply this by, looks like 4a. So 4a on the bottom, then 4a on the top. And this is a common denominator. Now we can solve this. So we'll get x plus b over 2a squared equals b squared minus 4ac over 4a squared, like we should. And then we take the square root of both sides. And when we do that, we want a plus minus here. And nicely, if we do that, we're going to get this x plus b over 2a equals plus minus b squared minus 4ac all over 2a, because that 4 and that a will go down. And then we add this over, or subtract that over, I mean. And we'll get our quadratic form. Negative b And the a's, 2a's is the same denominator, so plus minus square root b squared minus 4ac all over 2a. And we can test whether this is true or not in a separate situation, but all it is going back to this one. If we have some numbers for a, b, and c, say a is 1, b is 1, c is 1, then we'll just be able to do something. It's been a while since I factored. That's not easy. This would be 2. That would be 1. There. So we'll get x plus 1 squared, like that, equals 0, and then x will be negative 1. So if we do the same thing here, where a is 1, b is 2, c is 1, we can just plug in that formula. So b is 2, and I'll do it here. Negative 2 plus minus 2 squared minus 4 times 1 over 2 times 1. And this is going to be 0, 4 minus 4 square root is going to be 0, and we're going to get x equals negative 2 over 2, or negative 1, like we should. So it works, long story short. Now, let's use the fact that we can use this quadratic formula, and let's do that with our equation. Let me re-get that, pick that up again. I could use this actually. There's another quick way to get that. I could plug in what VF is, so just AT plus VI, that goes here. So this is going to be 1/2, so that's 2 VI, oh, that's T, there, forgot that, plus AT, and then times T. So nicely, we distribute this 1/2 and this T to everything, and we'll get 2 over 2 v initial plus 1/2 AT squared. So another way to do that, T. And we can also subtract this delta x, because to use that equation, we have to have delta x on both sides. And we have to set it up like so. T squared, because we have to put it in standard form, or plus v initial t plus negative delta x. All right. So this is our A, this is our B, and this is our C. And we can set everything up into our equation. So we'll do that over here. Let's see if I have space here. So T equals negative B, negative VI, plus minus square root VI squared minus 4. A is going to be 1/2 of little a, and C is going to be some change in x, which is negative, so that becomes positive, and there's delta x as well, all over 2a, which is going to be 2 over 2 times little a. So time becomes negative v initial plus minus square root v initial squared plus 2 times a delta x. all over A, which is what we have in there. All right, and that's it.